V8 allows you to capture a heap snapshot, a full picture of memory distribution across all objects at a point in time. It shows what objects your code uses, how many of each are alive, and how the application changes over time if you request snapshots repeatedly. There are several approaches to capturing heap snapshots. The first approach uses Node Inspector. Install it globally with npm install g node inspector. Started with the Node Inspector command, it will tell you a local URL in the browser where you can view your application. Then start your own program with the debug flag, node debug leaky.js. Open Node Inspector's URL in your browser, go to the Profiles tab, choose Take Heap Snapshot, and click Take Snapshot. Take multiple snapshots over time. You'll see them accumulate in the sidebar. If your snapshots are growing in size, that's your leak. Select the latest snapshot and compare it to the first. You'll see a delta column. Positive delta means more objects were created than destroyed. The constructor list shows which types are growing. The second approach uses the V8 Profiler npm module directly in your code. This lets you take snapshots programmatically and check things like how many nodes are in the stack at a given moment using profiler.takesnapshot.nodesCount. This is useful for automated leak detection in test environments. You can also use the trace_gc flag when running Node, for example node trace_gc leaky.js. This prints every GC action to the console, the scavenge operations on new space and the mark sweep operations on old space, with timestamps and memory transitions. From these trace lines, you can see exactly when GC is working hard and whether the old space is growing. Beyond Node Inspector and V8 Profiler, two npm modules are particularly useful for production memory monitoring. The first is Heap Dump. It lets you dump a heap snapshot to disk without running in debug mode. Install it with npm install heap dump. Then in your code, call heapdump.writeSnapshot with a file name. A common pattern is to write a snapshot every hour and keep the last 10 to 20. This gives you an offline record you can load into Node Inspector's load button to analyze without the overhead of live debugging. The snapshots are synchronous, so your program will pause briefly while writing. Be aware of this for large heaps. The second module is memwatchNext. This one is simpler, no debug flag, no inspector needed. memwatchNext watches for heap size changes after GC sweeps and compacts. It emits a leak event when the heap is constantly growing, meaning more memory is allocated than freed across multiple GC cycles. It also emits a stats event with information about full GC cycles, how many cycles, current heap size in bytes. This is particularly useful as a passive sentinel in production. Just require it, listen for the leak event, and log when it fires. memwatchNext also has a heapdiff feature. Create a heapdiff object, run your code, then call heapdiff.end to get a before/after comparison of the heap showing nodes freed, nodes allocated, and the change.details array which lists which constructors changed. If you have a suspected leak, the constructor showing the largest positive delta in change.details is your culprit. Finally, think about third-party services for heavy memory workloads. Node.js runs on memory. If it fails, all in-memory data is lost. For large object structures, move storage outside the process, Memcached or Redis for key value and lists, MongoDB or Elasticsearch for documents, HBase for MapReduce workloads, OrientDB for graph data, Ryak for large binary data. These services are optimized for specific workloads, support concurrent access, and survive process restarts, dramatically reducing your Node.js memory footprint.